Hello everybody, my name is Narendra Kumar and we are from Narendra Academy. And in the last class, we did a lab activity in which we verified the angle of incidence is equal to angle of reflection and the incident ray, normal and reflected ray lie in the same plane. Now today we'll do very important concept. We think it's very simple, you stand in front of the mirror and you can know. Okay, you can know, but why is it happening? You can know the distance between you and the mirror is the same as the distance between the mirror and the image. Suppose I stand in front of the mirror, the distance between me and the mirror is equal to distance between the mirror and the image. Also we know that my right ear will be that side. From in the image it will be, so it is laterally inverted, not this way, laterally inverted. All that we know. The real question is, why is it like that? Why are the images formed that way? That is a crucial point. Many people take it for granted. It is not a thing to take for granted. There is a concept, there is a logic there. Very beautiful logic and very simple. Formation of an image by a plane mirror. Now I'll make a diagram. Listen carefully. You have a mirror like this. So this is a mirror. I'm drawing what is called figure 8 here. This is an object. O is an object. And from here it comes a straight line. So here there is a normal. And then it goes like this. One more ray. There's a normal here. It goes like this. So something like that. You can do it geometrically. So this meets here and this meets here. See, it's very strange. This reflected ray meets here and this reflected ray meets here. So the O is a point object. Some rays from O reach the mirror and get reflected. You can make many rays. You can make hundreds of rays, you can make infinite number of rays, but 2 rays are enough. Why are 2 rays enough? Because 2 rays if you have, we'll know where they meet. See, suppose I have another ray, they will also meet there. 4th ray, that also will meet here. 5th ray, that also will meet here. You understand? So 2 rays are enough. 1 ray is not enough, because if I don't draw this ray, then I won't know where the object will form. I mean, where will the image form? I won't know. So 2 rays are enough to form an image in any kind of mirror. Okay, that's clear. O is a point object. Some rays from O reach the mirror and get reflected. When we look into the mirror, the reflected rays seem to be coming from point I. So this is not O dash, he has put I here. Image is a better word, better letter. Suppose you are here or here, anywhere, all the rays seem to be coming from one point. If you keep your eye here or anywhere, because the rays will come there, but they all come here. So wherever your eye is, it looks as if the rays are coming from there. It looks as if the rays are coming from there. It's so interesting. See, this is not a real image, it's a virtual image. It's not really there. This object is not really here. But then why is it seen there? That is a wonder of nature. When you stand in front of the mirror, why are you inside? You can't be inside. It's not a real thing. It's not a ghost or something. Okay, it is a kind of illusion which is virtual. We call it virtual image. So this is a virtual image, not real. It's not really there. So this comes here. So if you keep your eye, the eye doesn't know anything. It looks as if it's coming from here. So it's pure geometry. It's pure geometry. This ray comes and reflects here. See, you can see the angle also. And you can see the angle. It's going little this way. As it goes like that. See, if I take one more ray, it will go like something like this. Not so much. Like this. See, little bit. So this will go and converge there. See, as you come this way, the rays come this way. These reflected goes away like that and they converge there. You understand? It's pure geometry. So we don't need the third ray. We don't need this third ray. So only for explanation I kept it here. So that's a beautiful point he says in one sentence. This sentence is crucial. When we look into the mirror, the reflected rays seem to be coming from the point I. They seem to be coming from the point, wherever you keep your eye anywhere, they seem to be coming from there. So point I is the image of point object O. Observe the distances of object O and image I. Observe the distances from the mirror, from the surface of the mirror, and try to compare these distances by approximate estimation. In figure 8, we find that these distances are equal. Purely out of geometry, this distance, let's say this is K, Ik is equal to Ko. Ik is equal to Ko. Let us assume that an object O dash. Now this is a point object, but normally objects are something like this. Objects are something like this. Then what happens? Then what do we do when objects are something like, we take the top and we take the bottom. That's what we will do next. So now we are not taking a point object. We are not taking a point object. We are taking a vertical object, like this marker which I have in my hand. Something very similar to that. So we have another diagram now. So we'll make the diagram first. So you have O here, and you have a object O dash. O dash is the object. So what will you do? Like how for O we found out the I, we'll find for O the I, for O dash the I dash, and we'll join I dash. Then we'll get the object as the image here. So obviously what will happen? So this will they have drawn in the textbook, they have drawn like this. So this will be the normal, will go like this, and O, and here it goes like this. Here it goes like this, and there's a normal here, so it goes like this. Got it? Not so much. A little less. This is the incident rays, the reflected ray angle will be like this. So these are the two. Then he took one more here, so O will come here, and he took one more here, and that will go that side. I'll explain again. See, he took O, he took two rays. One ray goes like this and comes out like this. One ray goes like this and comes out like this. This is for O. So where will the image be? O, the image will be somewhere. This line will come like this, right? And this will come like this. So your O dash is here. Similarly, your I dash will form somewhere there. How will you get I dash? This image went there, so this will go like this. See? So what we did earlier, how O got I, we are getting O got I here, this is I, sorry, and this is O dash got I dash. So instead of taking one point, one image, we got top point and bottom point, and we got the image here. So if I take middle points, they'll come here, one point here, they'll come here, all these points will come like this. So that we don't need to do. We know the top point and the bottom point. The top point's image is here, the bottom point image is here, just like before. So this is nothing new. The diagram could be a little complicated, but there's nothing new. So this goes like this. So these two are converging. So wherever you are, it look as if this point is here. It look as if this point is here, this point is there, that point is here, that point comes here. So this image, this is the image formed. Let us assume that an object, now I'm going to read the textbook. Let us assume that an object O dash is kept in front of a mirror. Draw a few incident rays from the object to the mirror. We did that. And reflected rays from the mirror using laws of reflection. Laws of angle of incidence is equal to angle of reflection. Your drawing may look like that, shown in the figure. So this is the drawing. In the figure, the rays coming from the point O get reflected from the mirror and seem to be coming from point I. So we say I is the image of O. The rays coming from the point O dash, where will they be? Yes, I dash. They seem to be coming from I dash. So I dash is the image of, so we say I dash is the image of O dash. The rays coming from the middle part of O and O dash will form their own images between I and I dash. I told that also. Thus, I dash is the image of the object O dash. So we got this image. This is here. What is the size of the image compared to the size of the object? What is the size of the image compared to the size of the object? Let us discuss some of the characteristics like size, distance, and right-left inversion. Right-left inversion is if I am standing in front of the mirror, my right eye does not come there, it comes there. Inversion laterally. And my left ear comes there. So let us discuss some of the characteristics like size, object size, image size. Distance means from the mirror. Object to the mirror, mirror to the image. And right-left inversion of an image formed by a plane mirror. That we'll do in the next lesson. This is Narendra Kumar and we are from Narendra Academy.